Hello, welcome to my channel. Okay, so what I wanted to do is have once a week trying to get this started on recording some of the Spike research or just trying some new tools or reading some documentation and see what I can make with that. This time I wanted to focus a little bit on code. It's something that I've been trying to figure it out for a project that I cannot talk right now, but or I'm planning to talk in the future. But this project uses SQLite as database and it's written in Crystal language, right? And using the official Crystal SQLite database or adapter, it has some limitations on what you can provide to that database to get started. So this time I'm going to be focusing on that. This is the limitation I'm talking about is the PRAGMAs. Normally you will need to do something like this. So you will need to open the connection. So this is how the SQLite adapter for CrystalDB works. You pass the file parameter, and then with that you need to do setup connection in order to run certain PRAGMAs. PRAGMAs are little adjustments that you can do to the SQLite engine, which is an embedded database that will be part of your executable. It's an embedded library, and that's going to adjust how the engine is going to work. So when you do this approach, kind of like you're binding your application implementation to that specific database engine. So if you wanted to create a tool that is more generic, that will adapt to different things, it's not going to work quite efficiently. So you're forced to do this kind of thing with setup connection, execute on that. You can execute then the PRAGMAs that you need, and then you execute your code, right? What I'm thinking about is how we can free ourselves from that and take some learnings from the Go library, the Go, how they manage the database connections and things like that. They already have also an official adapter and things like that, and they use what's called a DSN or data source name. And using that data source name, you can pass query parameters where certain things, and those things are going to adjust how that database engine works. So for example, in the case of MySQL or MariaDB or Postgres, you can pass that you wanted to enable TLS and that you wanted to enable what is the key or what is the certificate in order to connect to that remote server. Or other details are going to adjust how the connections to that database engine is going to work. In the case of SQLite, there's plenty of those things I was mentioning to you. They're called PRAGMAs, and PRAGMAs are a full list of things that you can adjust. Just to give you an example, if you wanted to have concurrent access to the database or write to be queued or waited until another connection or another thread is reading those things, you have things to adjust. Foreign keys, if you wanted to have like integrity with foreign keys, you need to enable that and things like that. So what I wanted to do is to see if I can do that implementation. Right now that's not possible with the current Crystal SQLite adapter. There is, if I go to the connection on SQLite, there's a to-do about using flag URI parameter instead. And the thing with this is it's quite limited in relation to what you can do with flag URI, what it works. So for example, you could adjust the kind of like the database that you wanted to use, or you can adjust a couple of parameters, but it doesn't give you the full spectrum of the things that you can access or you can change when you're doing PRAGMAs. So for example, if we go here to the SQLite documentation and we go here, I'm just going to search for the URI function, and when you use the URI file name that I was mentioning to you, if I search OpenURI, when you use this OpenURI, it changes how the open function works. And when it changes that, it allows you to do a couple of things. I was mentioning to you, like the mode, if you want to have read-only, tweak a little bit of the cache, if you wanted to have immutability, or the virtual file system, and that's it. But the other pragmas that I was mentioning to you, they're not accessible. So for example, let's say that you wanted to create an application that uses SQLite as a database, and you wanted to take advantage of those things. You were forced to encode that in your code, like this. But if you wanted to have more flexibility, that what I was talking at the beginning, maybe you wanted to read this from a environment variable that contains the variable. So following the standard of reading that from database URL, for example, and things like that. So what I'm going to do is to see if I can implement that, right? The idea will be where I need to put that into the Crystal SQLite when a connection is created, right? Because this needs to be applied, the pragmas needs to be applied to, well, certain pragmas needs to be applied to a connection. Certain pragmas are database wide. So once those are set, are applied to the database. And we can talk a little bit later, show a little bit of example. Also, as I was mentioning, like maybe get some parity or some similarity on other implementations. I was mentioning to you the Go implementation for the query parameter, the connection string as they call it for the DSN. They already have a list on the query parameters, how they're supported. So maybe use something similar to this, like expose those in a similar way, and then that way kind of like there's a convention on how that works and things like that, right? Next, try to figure out what the SQLite3 APIs, you need to perform those one-off without having to do a prepare statement, execute that and finalize that prepare statement because that's necessary for SQLite, and then write some specs to see if we can do it, right? Okay, so let's get started. I actually already set it up something here on my connection spec because we're talking about we need to be implemented this on the connection, and I created a private method called itSetPragmaOnConnection that basically it writes an it for my specs with open up a connection, set it up the query parameter, the options that you pass, the value, and then it's going to verify that pragma getting applied, right? So how that works on a SQLite database. If I do SQLite3 file db, okay, if I do pragma bc timeout, one of the things that I was checking out by default is 0. If I do a setting of 100 and then I query, I get, 1,000, I get 1,000, right? So that's how it works. If I quit and open again, for this database, if I do again pragma bc timeout, I get 0. That's not persistent. There are other pragmas that are persistent. So for example, journal mode, wall mode, which is a write ahead log that allows you to have more concurrency scenarios that you can use. If I do that and I query for the journal mode, I get the text, not at the string, I get the text with the wall mode. If I exit and come again, that is persistent. So once you change the journal mode, that gets written to the database and that changes all the connections automatically. So you might not need to set that up again, but you can set it up with the connection string. So coming back to the spec that I was mentioning, I have this helper, and then I wrote some examples and I commented those out right now. So I say it says PRAGMAOnConnection for BC timeout. I'm going to follow the same convention as I mentioned it for the Go adapter for SQLite. That says like underscore BC timeout, and I pass a value of 1,000, and that value gets returned. This is the expected value that we'll get back is 1,000 too, right? And then I have another spec that says BC timeout with another alias called timeout 2000 and 2000 and so on, and then I can do the foreign keys, asynchronous mode, journal mode, etc. Right now, I'm not going to focus on that. I'm just going to try to see if I can get one of those things implemented, right? So I was mentioning before, this is the functionality when a new database connection is open for SQLite. It passes the database, it does the super, so it does all the things inherited from the default DB connection, the base class, grabs the file name that then is used for the open of the database. It registers the function for the regular expressions, and there is this to do that I was mentioning, flag URI, right? So what I'm going to do here, I'm going to split the screen and I'm going to run on my auto test connection. I'm just going to save that just to see if I can get the specs working for the project, right? I already did the shard install and I got all the dependencies necessary for this to run. And of course, that is a failure because BC timeout on a new connection is always 0, right? So what I need to do here is to find a way to get that to respond with the right thing. So following some TDD kind of approach, I will need to write here a way for me to do pragma BC timeout equal 1000 and send that to the database that I have open already, right? Now, there is a way, it's called one-step query execution, is called exec, to be precise, SQLite3 underscore exec, that's the function, that you pass the database, that you pass the SQL code or sentences that you need to evaluate, a callback, the first argument of that callback, and the error message that you can get sent back to you, right? And basically, if you call this with the database, with the query that you need to send, and then well, we don't need a callback, right? And maybe we don't want to capture the error message coming back from it, right? So this does all the things for us. It prepares the statement, executes the statement, and then finalizes that statement that was created automatically for you in a single call. So that will be something like this. Will be something like SQLite exec, right? And I will be passing the DB, I will be passing the query that I'm just mentioning to you. So there will be the pragma BC timeout 1000. And I was mentioning to you there is a callback thing, so I will not pass anything for a callback, something like that. So no callback, no error message to be captured, nothing. And this is a function that if it fails or not, it will return the second parameter. The application parameter is a valid connection, not closed. If the callback returns 0, well, following the logic of this, if this returns 0, the function executed correctly. If this returns something that is not 0, the function fails, right? So there is a definition here called check that's going to validate on that, and if not, it's going to raise an exception. So I will just do check on that. Of course, if I run that, it tells me that exec doesn't exist, right? Because, well, it doesn't. So what I'm going to do now is go to libsqlite3, where is the interface to the C library for SQLite, and I have here all the definitions for functions and things like that, blah, blah, blah. So what I'm going to do is right here, I'm going to run the exec function that's going to be called SQLite3 exec, and we pass the database, we pass the the SQL, and here what are the other parameters? We have the callback, and then we have the first argument to the callback, and then the error message. So what I'm going to write it here is going to be the pointer to the callback, and we have the callback definition there, and then the first argument, so this is a pointer to the first argument, callback args, right? And this is going to be, I'm just going to do like that. And what are the other parameter? The end message that I wanted to do. So I'm just going to do error message as the return. It's going to be a pointer to a pointer to that. And this is an int32 response, right? What can go wrong? I will just save the auto load, indicate that that might be an int. Oh, sorry. This needs to be a pointer to a string, to a C string. So like that, save it. Now it's compiling. At least it's not blowing up. And it passes, right? Well, that's great, no? Okay, so it passes. If we come back here and I uncomment this and save it, so now we have two expecs, one that it checks for busy timeout, one that checks for busy timeout underscore timeout. This one now fails because, of course, I hard-coded this here. So what we'll need to do next, right? Next, we will like to move this to something that we can process for processing all the query parameters. So with the query parameters in a URL, we have it here, the database URI, and the database URI is a Crystal object that has the query parameters. When you parse that, you can query parameters and you get the parameters for ID, for limit, and things like that, right? But since I don't know what are the parameters that are going to be passed, normally you have the query as a string with all the values concatenated. So I was thinking on this test that I have here, if I parse those manually, right? If I parse those manually, I can loop through that, get the key, get the value automatically. So if I do this and I do ampersand timeout and I set it up 2000, right? And I'm going to execute that file here, Crystal run 1. I'm going to get the key and the value that I pass it to that. So the structure that I would like to construct is maybe a hash that I define as the key of this is going to be the pragma that I need to pass, and the value of it, so the pragma is going to be BC timeout, and the value for that pragma is going to be 1000. But if I call that using the different alias, it will need to be updated to be that, to be 2000. So the method that I would like to create, let's call that process query params, and we'll pass here the URI, right? So here what we're going to do, we're going to construct that that list of pragmas that were identified. So first what we're going to do, we're going to do URI params parse, and we're going to say parse the URI query. And since this can be nil can be, could be that, we're going to do like that. This is going to be key and value. So if we do this, and we're going to move that here, and I'm going to do here process query parameters with database URI. Here what we're going to do is check for each of the keys and then assign the values to that. So first we need to collect the values. So what I'm going to do here is just to call it PRAGMAs, and this is going to be a hash of string, right? And that's what I'm going to use to hold the pragmas that I set. So what I'm going to do is now determine the different pragmas or keys that we're receiving on the URL, and then based on that, assign it the right pragma. So I'm going to do a case key, and what's going to be here on the conditions, I'm going to do the condition is going to be BC timeout, and it's also going to be timeout. And with that, I'm going to do pragmas BC timeout without the underscore is going to equal the value that I just got on the query, right? And I'm going to process that for each of the elements. And what I need to do now with those hashes, I need to build what's going to be the URL, the SQL that's going to be executed by the database, right? First thing, what I can do instead of doing this, we can go into that later, but just as a proof of concept, I'm just going to write it here. I'm going to call execute directly, right? I'm going to do check SQLite exec, and I'm going to pass the DB as we had, and I'm going to do pragma BC timeout. This, it's going to be the query parameter that I just passed, right? The value, and that's going to be executed. If I do that, right, and I save, and I come to the screen, it's compiling, passes. And it passes the two scenarios, the one that was failing before because it was hard-coded. So that's great. But the problem with this is that it's going to be executing for BC timeout, is going to execute one pragma, and then it's going to execute another time, it's going to execute the second pragma to set that out. So the idea of like storing that in a hash will be a way of like collecting all those things and then passing those things to the database. And the good thing about this is that you can have multiple semicolon separated SQL statements on the second argument of this. So I could concatenate all the pragmas in one thing. So what I'm going to do now, I'm going to build that SQL command that we're going to run, and I'm going to use a string build, which is a functionality of Crystal. Here on string allows you to build a string, and you can pass those things in, and then be able to have multiple values. So what I'm going to do is define that, right? And I'm going to do that. I'm going to just call it S or string, right? And then what I'm going to do is iterate over the pragmas hash, right? And what I get from here, I'm going to do str, the string that I was creating. I'm going to do pragma, and it's going to be the key, which is going to be the pragma, and the value, which is going to be the value for that pragma, right? And that's how we're going to separate each of the pragmas, and we're going to get, from this, we're going to get a single string to execute, and then we're going to execute this at the end, right? So here, just going to go call check, and instead of doing the pragma here, I'm just going to do on the SQL that I just did, right? And well, let's see how that goes. Come back, we shall see that it passes or fails. Let's see. Passes. Perfect. So the next thing that we need to do is add more pragmas, right? We'll need to go and add the foreign keys with the different aliases. So for example, if we get the inspiration from the mat that I was mentioning, we have foreign keys here, which is underscore foreign keys and foreign keys here. And what I can do here, I'm going to duplicate this. And this is interesting on SQLite. This one you can have multiple values to indicate yes or one or on. You can use one, yes, true, or on. And for this key in particular, you're going to get a number as a response when it's true or false. So you're going to get 0 by default for the foreign keys, or you're going to get 1. So what I was mentioning here, if I go to the SQLite3, the database that I was mentioning, if I do pragma foreign keys, it's 0 by default. So that's why it's not worth it to test that out. But what I can do is do that, and I can do foreign keys and the FK with the aliases. If I save, now we got the 2 errors that I was mentioning. It sets a foreign key to 1 using the foreign keys aliases, and of course that doesn't work because I don't have a case for that. So I'm going to add a case, and it's going to be foreign keys, and it's going to be underscore FK foreign key, and this is going to be foreign keys, and it's going to pass the value that we set, or we can just hard code it in this particular case, because the value, if we're passing foreign keys, is going to turn that on by default. So we could do that, but I will just leave it that way. And then if we execute it, it passes, and voila. So kind of like that was what I wanted to do, like write some specs, make it that pass. The idea with this is that I can go and submit this to I already asked this as an issue on GitHub. What I would like to do is, because I was trying to do this in a different way, and it was blowing up all the code and things like that, so trying to find a better way to do it. And then I thought about, like, well, maybe I just need to go really low level and do it on the SQLite3 API directly, right? And that's it. That's what I did. So, sorry, that's all. I hope that you enjoyed what I just did. If you have questions, just leave it in the comments. I will try to post this also on my website here on the Things I Learned section, which I have the article from last week, and I will try to put all the snippets of code, the changes, and the link to the pull request when I submit it. I will try to do it this weekend. And that's all. Thank you for your time, and have fun.